Alright, so let's start now. Looks like only two of you have joined today. So anyway, I will be starting with with this week's material. So okay. So before I start, can I, since only there are only two guys, so I would like to have a one-to-one interaction with you. So till now, what is your experience with the course? So how did you feel about the course? Did you learn something? So you can unmute yourself and talk to me. Hello guys. Hello. Karthik. Am I audible? Hello. Okay, so looks like you do not want to respond. But that's okay. Yeah, yeah, Karthik, so you are not saying anything. Or are you saying something I'm not hearing? Is that it? Hello? Hello? Karthik, can you please speak? I'm not able to hear anything. Am I audible? Am I audible to you?
Yes, sir.
Oh, fine. Thank God. So I thought something had happened. So okay, so I was saying that so there were two students, but now only you are left. So I would like to have a one-to-one interaction with you about the course and what is your feedback about the course in general. So did you learn something? Are you enjoying this course? Hello. Okay, no problem. I will anyway start with this week's material. Is this visible? Is my screen visible?
Yes, sir.
Okay, fine. Okay, one second. Okay, so firstly I'll introduce myself once again. So this course is basic electrical circuits, and it is taken by your instructor Dr. Ankush Sharma. He is a professor in the Department of Electrical Engineering, IIT Kanpur. I will be your tutor for this course. These sessions that I will be taking will be tutorial sessions. And my name is Bayan Kanpur. I am a PhD student and a PMR scholar. I am also from the Department of Electrical Engineering at IIT Kanpur. So this okay, moving ahead. So this okay, so there is a mistake here. It is week 4. Okay, so I will correct it. So in week 4 you learned some more some more network theorems. So I will quickly summarize them. What was that? So you learned about Norton's theorem. So in the last week you learned about the week that was previous to this one, which is like week 3. So in week 3 you learned about Thevenin's theorem, and this week you are learning about Norton's theorem. Then you also came across maximum power transfer theorem, which is kind of an important one because yeah, it's an important one. It finds its application at many places. After that, you learnt about reciprocity and compensation theorem. So these two theorems, reciprocity and compensation, they are very important theorems. So reciprocity theorem is very important because it helps you to uh, like solve complex circuits problems very easily because you can transform your circuits in some manner and it becomes quite easier if you're familiar with reciprocity. But word of caution is that reciprocity is strictly valid only for linear circuits. They are not valid for non-linear circuits. So linear time invariant circuits, that is where reciprocity can be applied. Same goes for compensation theorem also. It is also applicable only for linear time invariant circuits. Fine. So moving ahead. Yeah, so this week I will not be, so as in my experience I have seen that uh, over the past 3 weeks I was quickly summarizing the topics that were covered in the lectures, and then I was moving on to the problems. But as it happened that I was not getting enough time to cover the sample problems. This week I have decided not to not to summarize the lectures and directly jump onto the sample questions, so that it will benefit you all. So if you have any doubt anyway in the theory part, you can ask me anyway anytime you want. So fine, you can interrupt me anytime and you can ask me whatever doubt you have in the theory part. I will be doing the questions now. Fine, so this is a question that I would like you to try. So Karthik there is, right? Hello? Hello Karthik.
Yes, sir.
Can you try this question? Can you tell me what should be done?
Yes, sir. Okay, sir.
Yeah, so you can speak up and you can say what do you think should be done here.
First of all, we want to find Rn, sir.
What do you want to find
First,
first of all?
after the, so first of all, we want to find Rn, sir.
R resistor.
Rn, sir. Resistor, sir.
Oh, okay. You are saying that. Okay, so let me clear it up. It will be better if I go to another one. So hold on a second. Okay, this will be. Hold on a second. Okay, so yeah, tell me what were you saying? What should be done here? Hello, Karthik. Am I audible? Is my screen visible?
Yes, sir.
Yeah, so you were saying something. So what do you want to do here? So the question is that you want to find out what is the maximum power that can be transferred here, isn't it?
Yes, sir.
P max, which can be transferred to this uh, yeah, to this across AB. What is the maximum power that can be transferred? So what should you do? Tell me. You were saying something. You were saying that first you have to find Rn. So what do you mean by Rn? So you
Road,
were saying that we have to
Sir,
find Rn.
resistance.
road resistance.
What is that? Load resistance you are saying.
Yes, L.
Oh, RL you are saying. Okay, okay, sorry, my bad. Okay. You want to find load resistance. So but the load resistance is not given here. So what do you think we should do?
We apply Thevenin theorem and apply resistance across ABs.
Correct. So you first want to find what is the resistance when seen from these terminals, right? Across AB. Correct? You first want to find out what is the Thevenin resistance, right? Fine.
Yes,
So
sir.
how will you find Thevenin resistance? So let me write
Uh,
it here. One second. Let me write it here. So step 1. What do you want to do? Find out Thevenin resistance across AB. Right. This is what you are saying. So what should we do?
Here, dependent voltage source are present.
Yeah.
So we take a independent 1 volt source या any voltage source
Hmm.
एंड जो वोल्टेज सोर्स से जो भी करंट निकलेगा वो वोल्टेज सोर्स और रेशियो का निकाल देंगे वो में आर ए बी
Okay. So
निकल
you are
जाएगा.
saying we should connect a voltage source here
Yes, sir.
correct? Between these
Yes,
terminals
sir.
and this terminals, right? This should be 1 volt. Okay, and what else? You want to find out
Uh,
what is the current coming out here,
yes,
correct? And you want to find out basically V upon I, which is in this case V
yes,
is 1 volt, so 1 upon I you want to find out. So you will get what? You will get the resistance, isn't it?
yes, sir.
Yeah, so how should you do? So is it only basically what you said was true, but is it complete, that statement? Aren't you, don't you think you're losing something here? You're missing out on something here. There's a very important point when you want to find out the Thevenin resistance. What is that? I think you're missing something. So what happens to this 8 volt here when you want to find the Thevenin resistance?
फर्स्ट
सर
हम लोग
शॉर्ट
वहां से करंट निकालेंगे सर, और वो जो वैल्यू होगा वो सेकंड सर्किट में मतलब 120 जो है भी नॉट, मतलब सबसे पहले भी नॉट निकालेंगे सर,
हाँ,
फर्स्ट मेष में केवीएल लगाकर, और
ओके
वो जो वोल्टेज निकलेगा वो वोल्टेज को वैल्यू पुट करेंगे 120 इंटू वी नॉट,
ओके
जो वी नॉट का वैल्यू आएगा सर, क्योंकि वहां पर मेरा इंडिपेंडेंट वोल्टेज सोर्स है, तो वहां से
ओके
वोल्टेज सोर्स से मेरा करंट निकलेगा, तो
ओके
हम लोग वहाँ वोल्टेज ड्रॉप कैलकुलेट कर सकते
ठीक
हैं।
है, कर सकते हैं. ओके, आफ्टर दैट यू वांट टू फाइंड आउट दिस V नॉट एंड यू विल फाइंड आउट दिस वोल्टेज 120 टू V नॉट, राइट?
जी और कैलकुलेट करेंगे और फिर पुट कर देंगे।
हाँ, तो लेकिन क्यों, मीन्स व्हाट हैपेंस टू दिस 8 वोल्ट जब when we are calculating this output resistance or Thevenin resistance at the across the terminals A and B, don't you remember that we need to first short all the independent sources, sorry, we need to desensitize all the independent sources in the circuit. So what is the circuit here? Circuit is only this much, circuit is this much, correct? And what are the independent sources here? Independent sources this one only, isn't it? So for finding the Thevenin resistance, we have to first desensitize it. We have to make this voltage source as if it was not even present there. We have to make its value 0, isn't it? That is what it was. So if in a linear circuit, if you want to find, suppose you have a so there is this is terminal A, this is terminal B, right? Now this is your circuit. If you want to find the Thevenin resistance across these terminals A and B, what you need to do is that you need to first desensitize all the independent sources. What do I mean by independent sources? That there will be some voltage sources, isn't it? There will be some voltage sources, there will be some current sources. So you need to make them equal to 0. So if you make the voltage source voltage is equal to 0, what you will get? You will get as, so suppose if you have a voltage source of value V, suppose V is equal to V naught. If you make it equal to 0, if you make V naught equal to 0, what happens? You will get a short circuit, isn't it? What does that? What does this V naught represent? It represents the potential difference between this point and this point, isn't it?
Yes.
And when you want to reduce it to 0, when that potential difference, when this potential difference, when it becomes 0, what do you get? You get a short circuit, isn't it? In a simple wire, there is no potential difference between two points, isn't it?
Yes.
Right. So for a voltage source, if you want to desensitize it, you have to make it a short. Say, and for a what do you do for a current source? Suppose there is a current source here, which whose job is to make sure that this in between these two terminals there is a current I is equal to I naught flowing in this direction that I have shown, in this direction that this arrow points to. Suppose I want to make this I naught equal to 0. What does this mean? It means that in between these 2 points now there is no current flowing. What does that effectively mean? Is that now these 2 points are effectively open, isn't it? There can be no current flowing through this, right?
Yes.
Yeah, so what I'm asking is that what I'm saying is that when you try to find out the Thevenin resistance by doing all this voltage source and current thing, at that time you have to make sure that all the independent sources inside the network, they are all desensitized. If it is a voltage source, then you have to make sure that it is shorted, that basically this becomes shorted like this. If it is a current source, you have to remove that element and you have to make it an open circuit. Do you follow? Are you following my point now?
Yes, sir.
Right. So here basically, so let me remove all this. Okay, 1 second. Okay. Fine. So what do you need to do here is that you want to find out the Thevenin resistance here in between these two terminals, but for that first you have to desensitize it, isn't it? So how will your circuit look after desensitizing it? It will look like this. So there is a 3 ohm resistance, or let me make it clearer, this will confuse you. So how will it look? It will look like this. There is a 3 ohm, there is another 1 kilo ohm, oh sorry, this is 3 kilo ohm, this is 1 kilo ohm plus minus V naught. So there was a voltage source in between these and between this terminals, right? Now what we do is that we desensitize this voltage source and replace it with a short circuit here, correct? Now what happens is that we take, now your circuit looks like this. So this is, yeah, so we do not open or short circuit any of the dependent sources. I guess that that is already known to you, isn't it? Hello?
Yes, sir.
Yeah, so we do not open or short circuit any of the dependent sources. So this 120 times V naught, it's a dependent source. So we do not touch it. We do not try to remove it. Otherwise we will get erroneous results. This is 10 kilo ohms. After that, what? This is a 40 kilo ohms resistance. Fine. These two are short. These are all shorted, and then there is a ground here. Fine. And you have to find out the current here, I, because and this is 1 volt, as you said. You have to find out how much current is being flowing here. So when you short circuit these 2 points, what is effectively the current? Is there any current in this branch, in this mesh? Do you think there
No,
is
sir.
current?
Zero. Zero.
Correct. So basically current flowing in this branch is 0, right? So there will be definitely no voltage drop across this 1 kilo ohm resistor, right?
Yes.
Right. So V naught here becomes equal to 0, isn't it?
Yes.
Now if V naught here is 0, what is this voltage here?
0 volt.
Correct, 0 volt. So effectively what happens is that this is again
Short.
shorted to this point, right? This point
Yes.
here is shorted to this point, correct?
Yes.
Right? Now effectively your circuit becomes what? Tell me. What is your circuit now? So I will, yeah, so now your circuit becomes, so this part is gone, right? And this voltage source is also not there. So effectively your circuit becomes what? This is 10 kilo ohm, and then there is a 40 kilo ohm thing here, and it is these terminals here and here are shorted, right? And you have connected a plus 1 volt of voltage source, and you have to find out what is the current that this voltage source is providing here, isn't it? This is your A terminal, this is your B terminal. Now tell me, what is the what is the current that this is supplying here?
1 by 8, sir. Means 8 milliampere.
1 by 8.
10 किलो ओम और 40 किलो ओम का इक्विवेलेंट तो 8 किलो ओम होगा.
Okay, fine. So what? So yeah. So you directly said the answer. I wanted the step here. So are this what are these two? These are in parallel or these are in series? When seen from these two terminals. So how will they be
Parallel, sir.
parallel? Correct, right? So you have a 10 kilo and 40 kilo in parallel. So what it is? So effective resistance is what? 10 kilo ohm parallel 40 kilo ohm, right? So what does this become? 10k multiplied by 40k divided by 10 plus 40k, correct? So k gone. This becomes 400k divided by 50, which as you said correctly it becomes equal to 8k. So this becomes what? 1 by 8 milliampere. Correct? Right?
Yes.
Right. So what is the resistance now? So RAB equal to R Thevenin. What it is? It is equal to V by I. What was V? V was equal to 1 volt. And what is I? I is equal to 1 by 8 into 10 to the power minus 3. Is this point clear? What I have written here? Where is this 10 to the power minus 3 coming from? Tell me.
Milliampere means
Correct,
10
definitely.
to the minus
Yeah, right. That is why. So this point is clear, isn't it?
Yes.
So this means that R Thevenin is equal to what? It is equal to 8
8 kilo.
kilo ohm. Correct, very good. So Thevenin resistance is 8 kilo ohm. Fine? Fine. Now what I should do?
We find Thevenin voltage, sir, which is 0 volt.
Why? Why do you say that?
नो सर, नो सर, 0 वोल्ट नो सर, सॉरी सर, क्योंकि जब ये थेवेनिन वोल्टेज
One second, one second.
कैलकुलेट
Let me help you out. One second. So it will be better if I take this picture. If I copy this picture and place it here. Yeah. Tell me now. Now what you have to find? I will write it.
सबसे
Okay. I will write it. It will be better. So step 2 is that find the Thevenin's voltage. Correct. V Thevenin across A B. Right? This is what you are saying. So what do we do to find out the Thevenin voltage?
सबसे पहले हम लोग फर्स्ट मेश में केबी लगा कर वी नोट का कैलकुलेट करेंगे सर,
Okay.
और
So
वो वी नोट का वैल्यू पुट
yeah.
करेंगे
So
1
one by one. We will go to the steps one by one. Tell me what will be the V naught value. Tell me.
वी नोट वैल्यू इज 1 बाई 4 into 8 मीन्स 2
1
किलो.
by. Okay. So other guys who are there in the session, are they following this? So why is this 1 by 4 into 8? Can you
Means
understand,
2
other
volt.
guys? Hello, am I audible to other guys?
Yes, audible.
Yeah, Abhishek. So are you clear with why is this V naught is equal to 1 by 4 into 8?
Yes, voltage division.
Correct, definitely, yes, right. So if you all these things that I am doing here, if any of you have any doubt, just interrupt me. Okay, so I am moving forward with the assumption that one guy is answering, so that all others are also comfortable with that answer. So if you have any issues, just interrupt me. Otherwise, I'll feel that okay, so everyone is clear with that, and I'll move ahead. Okay.
Yes.
Fine. So after, yeah. So basically this will become equal to how much? 2, isn't it? 2 volts.
Yes, sir. 2.
Fine. So I have found out V naught. After that, what should I do?
We put dependence source में 120 V नॉट मीन्स 240 वोल्ट सर,
One second.
और उसके बाद सर वोल्टेज अक्रॉस
One
40
second.
किलो
One,
एम्पीयर.
one second. One second. One second. We'll go one step at a time. Yeah. So this will become 2 volts. Fine. After that, 120 into, you are saying this. We need
Yes.
to find this voltage, isn't it?
Yes.
And what will be this voltage? 120 into 2 volts. Correct? What will it be?
Yes.
240
240.
volts. And what will be the sign of this 240 volt? How will it be? So which terminal will be positive, which terminal will be negative?
सेम सर, जैसे ऊपर नेगेटिव है नीचे पॉजिटिव है वैसे ही.
Correct. So this is minus, this is plus. This becomes 240 volts. Isn't it? Fine. Now what should I do?
Again we apply voltage division rule sir across
Correct.
40.
Definitely. So what should I do? Tell me what will be the. So what is my final goal? What do I need to find here?
फाइनल को देख सर VAB हमको निकालना मींस
Right.
V.
Correct. VAB is the final goal. I need to find out what is VAB, this voltage. Notice the sign here, okay? This is plus, this is minus. So notice that sign. Okay, so now tell me what is VAB.
VAB is 40 by 50 into minus 240s.
Very, very good. Very good. So other guys, are you comfortable with this answer? Whatever he's saying?
Yes, sir. Comfortable.
Yeah. So this becomes 5 4s are 20 and 5 8s are 40. Right? So what will be this?
Yes.
Tell me.
192 volt minus 190.
Correct. Very good. So what is the fine? So yeah. So after that, what should you do? So now you have both the. Okay. Sorry. So step 3. So I will just write out what I have. I have VAB is equal to V Thevenin is equal to minus 192 volt. I have RAB is equal to R Thevenin is equal to how much? How much was it?
8, 8,
8 kilo
8.
ohms. Fine. Now what should I do?
With the Thevenin equivalent
Correct.
circuits.
So what is the Thevenin equivalent here?
A voltage source and in series with resistance.
Is this what you were saying?
What's it?
Is this what you were saying?
Yes.
Voltage source in
Yes.
series with,
Yes.
right? Okay, sorry, this is not. I should write it properly. This is right. This is what it is, and this is terminal A. This is terminal B. Fine. Now what should I do?
First, for maximum power transfer, load resistance is equal to Thevenin resistance.
Very,
So,
very good.
yeah.
One second. One second. Let me. Some people are trying to enter. So let me enter them. Yeah. Fine. So what you are saying is that